Hello, my name is Mary Amy Tembo, and I'm going to be talking about Introduction to User Interface Design. Sorry. Firstly, I'll talk about what user interface design is. It's a branch of design that deals majorly with creating the visual elements and interactive features of digital products such as websites, software applications, and other user interfaces. Uh, Below are some of the reasons why it's essential in development of digital products. It encourages engagement. A visually appealing and easy to use interface keeps users engaged longer, promoting more frequent interactions with the product. First impressions. UI design is often the first thing a user notices. A clean, aesthetically pleasing interface creates a positive first impression and can engage users instantly, while a poorly designed interface might turn them away. We have improving usability. A good UI design ensures that the product is easy to use, allowing users to complete tasks effectively without confusion or frustration. It enhances user experience. UI and UX are closely connected. A well-designed UI helps users easily navigate and interact with the product, improving usability, and overall user satisfaction. It increases accessibility. UI design ensures that digital products are accessible to a wide range of users, including those with disabilities. Considerations like font size, color, contrast, and clear navigation paths make products very inclusive. Brand identity. UI design helps establish and reinforce a product's or a company's brand identity through consistent use of colors, fonts, and size, making the product easily recognizable and memorable. It reduces error and frustration. A well thought out UI minimizes user errors by providing intuitive controls and clear clear labels, helpful feedback, leading to a smoother and more satisfying experience. Yeah. So next, we're going to be looking at the key principles of UI design. Firstly, we have visibility. When designing a product, it's important to make sure that the elements and system status are clearly visible to users. Then we have feedback. Provide immediate and clear feedback to users after they perform actions. Constraints. Design the interface in a way that prevents users from making mistakes or limits their actions to avoid choices to valid choices. Then consistency. Maintain consistency in the product layout, behavior, and appearance of the UI elements. Then we have affordance. Design elements should suggest how they are supposed to be used, like buttons that are clickable. Mapping. Ensure that the relationship between controls and their effects is logical and intuitive. We have flexibility. You provide users with multiple ways to complete tasks, such as keyboard shortcuts, customization options, or alternative workflows. Learnability. Design interfaces that are easy to learn, especially for new users. Iconography, creating or selecting icons that convey meaning and help users understand the functionality of different elements or actions within the interface. Then we have uh, types of UI design. Command line interfaces. Command line interfaces are text-based. So the user inputs a text command into the device that interacts with the computer's operating system. Then we have graphical user interfaces. They allow a user to interact with electronic devices through graphical icons and visual indicators. Web interfaces also allow a user to interact with with the web, with websites, but still using color scheme, typography, icons, buttons, menus that the people use to navigate the website. Then natural user interfaces. These are interfaces that engage with natural activities or meant, for example, voice, touch, gestures, basically. Then augmented reality. And the interfaces that overlay digital information and virtual objects onto the real world environment. Virtual reality interfaces are interfaces that immerse the user in a computer generated environment that simulates reality through the use of interactive devices which send and receive information and are worn as either headsets, goggles, gloves, or bodysuits. I think examples of natural user interfaces we have Siri. You speak, it recognizes your voice and receives a command. Alexa uses a natural user interface. Then we have mixed reality interfaces. They combine both VR and AR interfaces to create immersive experiences where the digital and physical world interact seamlessly. Microsoft HoloLens uses mixed reality interfaces. So next we're going to be looking at tools, UI design tools and technologies. We have prototyping tools. Prototyping tools are used to create early versions of a UI to test and refine ideas before full deployment. Examples include Figma and Sketch, maybe. Then wireframing, used to help create simple, low fidelity presentations of a UI. We have user interface design software, comprehensive tools for designing detailed and interactive user interfaces with extensive design features. We have usability testing tools that are used to evaluate how users interact with a UI to identify usability issues. Analytics tools, these tools collect and analyze data to analyze user behavior and improve the UI. For example, Google Analytics. Accessibility evaluation tools. Tools used to assess whether a UI is accessible to users with disabilities. Then version control, tools used to manage changes and collaborate on UI development. For example, GitHub, Bitbucket, design systems, collections of reusable components and designs to ensure consistency and efficiency in UI design. So next we're going to be looking at the UI design process. Yep. Firstly, we have research and discovery. You understand the user's need and the business objectives of the product. Key activities, we have user research, we have competitive analysis, business requirements. In user research, conduct interviews, surveys, or user observations to gather insights about the target audience, their behavior, goals, and pain points. Then competitive analysis. We analyze analyze competitors' products to identify design tools, strengths, and weaknesses. The business requirements define the product's goals and requirements by collaborating with stakeholders, product managers, developers. So next we're going to be having defining user personas and user journey. Here we create representations of target users and map out their interactions with the product. Key activities include the personas, user journeys. So for the personas, we develop user personas, fictional characters that represent different user types who might interact with the system. These personas help guide design decisions by focusing on specific user needs. For the user journeys, we map out the steps users take to achieve their goals within the product, highlighting key touch points and potential pain points. This helps identify the most critical areas to focus on in the design. Then information tech architecture is our third. We organize and structure content in a ways that users can easily navigate and find what they need. Key activities include site maps, wireflow, or user flows. We create a visual hierarchy of the site structure to ensure that content is organized logically. Define how users will move through the product, focusing on the interaction parts and ensuring that the experience is smooth and logical. Then we have wireframing. Create a low fidelity sketches or outlines that define the layout and structure of the interface without getting into detailed design elements. Key activities include wireframes, feedback, and iteration. For the wireframes, design wireframes screen or page outlining the placement of UI components like buttons, menus, images, and text. These are basic grayscale sketches that focus on functionality rather than aesthetics. So for feedback and iteration, collaborate with stakeholders and users to refine the wireframes based on feedback, making necessary changes early in the process before moving to detailed design. Then we have prototyping. Develop interactive high fidelity mockups that allow users and stakeholders to experience the interface and test its functionality. The key activities include interactive prototypes, user testing, iteration. So you create clickable or interactive prototypes using design tools like Figma, Sketch, Adobe XD to simulate the actual user experience. Then for user testing, you conduct usability tests with real users to observe how they interact with the prototype and identify areas for improvement. Then, based on the user feedback, make changes to the prototype to improve usability. Design. For visual design, we apply branding, color schemes, typography, and other visual elements to create an aesthetically pleasing and cohesive design. Key activities include UI design systems, develop a consistent set of guidelines, including color palettes, typography, iconography, and components to maintain a uniform look and feel across the product. High fidelity mockups is another activity. Refine the wireframes by applying visual design principles such as color, contrast, spacing, and imagery to create detailed polished mockups of the interface. Then micro interactions. Design small subtle animations, for example, hover states, button clicks to enhance the user experience and provide feedback during interactions. Then we have usability testing. Evaluate that designs effectiveness and use and ease of use by testing it with real users. Key activities include A/B testing. Here you test different kinds of the UI to see which design performs better in terms of the user interaction and KPIs. Then we have task-based testing. Observe how users complete specific tasks in the prototype, identifying any issues or areas of confusion. Then we gather feedback, collect qualitative and quantitative feedback to understand how users perceive the interface and what improvements can be made. We have development handoff. Provide the development team with necessary assets, specifications, and guidelines to build the interface. Key activities here we have design specs, then collaborate with developers. For design specs, we share detailed design documentation with developers, including pixel dimensions, spacing, colors, interaction guidelines. Collaborate with developers, ensure smooth communication between designers and developers through the build process, addressing any design concerns and or questions that arise during implementation. Then finally, we have post-launch monitoring and iteration. So for this, it's continuously monitor user interactions and gather feedback after the product is launched to refine and improve the UI. The key activities include analytics and data tracking, user feedback, continuous improvement. You analyze user behavior using tools like Google Analytics or Hotjar to see how users engage with the interface. Identify potential drop-off points or find areas needing improvement. User feedback. You collect user feedback through surveys, reviews, or customer support to gather quality insights. Then for continuous improvement, make iterations according to the feedback that you've been given and the data from the data analytics. Yeah, optimizing the UI over time to enhance user satisfaction and experience. So we are going to explain the difference between user experience design and UI design. So for UX design, it focuses on the overall experience a user has with a product or a service, while UI design focuses on the visual and interactive elements of a product, how it looks. Yeah, to enhance for UX design, it measurably enhances the user's overall journey and ensures satisfaction and efficiency in their interactions. Then for UI design, creates a visually appealing and interactive interference for users to engage with. UX design involves research, strategy, wireframing to ensure the product is user-friendly and functional. UI design involves designing the layouts, the colors, typography, and interactive elements. Usability, ease of use, and smooth user flow is for UX design, whereas UI design, aesthetics, responsiveness, and visual consistency are the focus. In UX design, user research, personas, user flows, wireframes, prototypes, and user testing are the focus, whereas for UI design, visual design, style guides, mockups, interaction patterns, and animations are the focus. So next, we're going to be looking at how UI designers work with UX designers to design a product. So we have collaboration on user research. UI designers conduct user research, they create personas and define the user journey. Then the UI designers use the information given and participate in the research to understand user needs and preferences. Then we have information architecture. UX designers organize and structure content to enhance usability. The UI designers ensure the visual hierarchy aligns with the information structure. Wireframing and prototyping. UX designers create wireframes and prototypes to map the flow and structure, while UX designers focus on visual aspects like the layout, typography, color schemes. Then we have user testing and feedback. UX designers conduct usability tests, refine functionality. Then the UI designers adjust visual design based on user feedback. Then design handoff. UI designers finalize the user flow and experience logic. Well, then the UI designers deliver detailed visual assets for development. So next we're going to be looking at some of the common UI design mistakes to avoid. Lack of user involvement. Designing without involving the end users often leads to interfaces that fail to meet the user's needs. We have poor feedback. Not providing users with clear and timely feedback about their actions leads to uncertainty and confusion. Then we have inconsistent design. Inconsistent use of UI elements such as varying fonts, button styles, or layouts can confuse users and make learning the interface more difficult. We have ignoring accessibility. Failing to design for users with disabilities can limit access to the interface for a significant portion of the population. We have overcomplicating the interface, adding too many features or cluttering the interface with too much information can overwhelm users. Unintuitive navigation, creating complex or hidden navigation paths can make it difficult for users to find what they are looking for. Overuse of metaphors. Using metaphors that are too abstract, outdated, or inconsistent can confuse users. Next, we're going to be looking at the key principles of good UI and their contribution. We have visibility. Visibility enhances user confidence by making it easier to understand what actions are possible and what is happening in the system at a given moment. We have feedback. It improves user satisfaction by reducing uncertainty and helping users correct mistakes quickly. Feedback helps users feel in control and reduces frustration. We have constraints. Design the interface in a way that prevents users from making mistakes or limits the action to valid choices. Yeah. This prevents user errors, making the interface easier to use and more reliable. By narrowing options, users are more likely to complete tasks correctly. Then we have consistency. It enhances usability by allowing users to transfer knowledge from one part of the interface to another, reducing the learning curve and increasing efficiency. We have affordance. It improves intuitiveness by making functions self-explanatory so users don't have to guess what they should do with a particular element. Mapping. reduces cognitive load and enhances the intuitiveness of the interface by making the cause and effect relationship clear, leading to a more natural user interaction. So the user knows when I do this, this happens. Yeah. Simplicity increases usability by reducing distractions and allowing users to focus on completing their tasks efficiently without being overwhelmed by unnecessary features or information. Learnability reduces the barrier to entry for new users, ensuring that they can easily become proficient in using the system, leading to a more enjoyable and efficient experience. So, we have the future of UI design. Mhm. Natural user interfaces and gestural interactions. This, as I said earlier, focuses on touch, speech, gestures. So you interact with the interface according to what you say, what you speak, your gestures. The future trend of this, as technology advances, user interfaces are moving beyond traditional graphical user interfaces to more natural forms of interaction, being touch, gestures, voice based inputs. Then the future impact is NUIs reduce reliance on physical controls and make interactions more intuitive, allowing users to interact with technology in ways that feel more human. Then we have AR and VR interfaces. The trend of AR and VR is that they are becoming prominent in UI design, offering immersive experiences that blend digital information with the physical world. These technologies enable designers to create interfaces that exist in 3D space, providing users with more immersive and context-aware interactions. Context-aware interfaces and ubiquitous computing. That's our third point. The future trend is UI design is moving towards creating context-aware systems that adapt to the user's environment, preferences, and activities. Context-aware interfaces can anticipate user needs and improve relevant information or options based on location, time, or activity, creating seamless experiences across devices. Then we have AI and ML in UI. AI and ML are being integrated into UI design to create smarter adaptive interfaces that can learn from user behavior and predict actions. AI-driven UIs can improve user interfaces by adapting to individual preferences, suggesting relevant content, or automating workflows, thus making interactions more efficient and personalized. Our fifth point is multi-device and cross-platform experiences. The future trend being a feature of UI design involves creating seamless experiences across multiple devices, including smartphones, wearables, tablets, and smart home devices. So, the impact designing for continuity across devices ensures that users can start tasks on one device. You can start a task on your tablet and finish it on your phone, or on your phone and finish it on your smartwatch, which promotes a more cohesive and convenient user experience. Then you have voice conversation interfaces. These are like chatbots and voice assistants. So the rise of voice controlled systems and conversational user interfaces is transforming how users interact with technology. The future impact: these interfaces remove the need for visual elements, enabling hands free interactions and making technology more accessible to a wider range of users, including those with disabilities. Then we have emphasis on ethical and inclusive design. The future trend: as technology advances, there is growing recognition of the importance of designing for ethics, privacy, and inclusivity in UI design. The future impact of this: uh, future UIs will need to consider not only functionality but also the ethical implications of design choices, ensuring that interfaces are accessible, non discriminatory, and respectful of user privacy. Then we have minimalist and intuitive design. The future trend of this UI design is likely to continue moving toward minimalism, where interfaces are simplified to focus on core functionalities and reduce cognitive load. Our future impact: minimalist interfaces will become more intuitive and efficient, allowing users to interact with systems in a more focused and streamlined way, reducing information overload. Haptic feedback and sensory interfaces. Advances in haptic technology and sensory feedback are enabling more tactile and immersive experiences in UI design. Future impact: haptic feedback will allow users to feel digital elements, enhancing immersion and making interaction more intuitive, especially in AR and VR environments. Then, lastly, we have emotional and empathetic design. UI design is increasingly focusing on creating interfaces that respond to users' emotional states and needs. So the future impact of this is emotional and empathetic design will lead to interfaces that can adapt to a user's mood, stress levels, or preferences, leading to a more human-centered interactions that cater for emotional well-being. Thank you for listening and watching. I will hand over to the next presenter.
So to describe the principles of human-centered design, we need to first understand what human-centered design, or UCD, is. It is a framework in design and development that focuses on the needs, preferences, and limitations of end users throughout the entire design process. The aim is to create products or systems that are more usable and accessible by involving users at every stage of the design. Yeah, it is a very core approach. So the principles of UCD include the following. There is focus on users and their needs, involvement of users throughout the design process, empathy and context, usability and accessibility, goal-driven design, prototyping and testing. And I think let's break them down a little bit. Focus on users and their needs. UCD thoroughly understands the users, first of all, who they are, their tasks, their goals and challenges. And this is done by the person, the designer, through research, various means of research like interviews, surveys, and very many others. Then there's involvement of users throughout the design process. Users are actively involved in every stage of the design process. From the initial research, this ensures their feedback is incorporated at each phase so as to keep track and know what the users think about the design. Empathy and context. Designers place themselves in the shoes of the users, empathizing with their struggles, their needs, and their daily realities. This includes understanding the context in which the projects or systems will be used, such as the environment, devices, and any potential accessibility concerns. Yeah, the designer tries to live out the life of the actual user so that they actually know, or to imagine themselves being the user so that they can create a design that actually would relate to them or to the users. Usability and accessibility. The end goal is to make the system easy to use. Yes, in user-centered design, the goal is to make sure that the system is easy to use for all the users. This can be done through clarity, prioritizing simplicity, and also ease of navigation. Yeah, goal-driven design is another principle. And to break it down further, I would say that UCD ensures that design solutions are driven by the user's goals and tasks. It emphasizes design for specific user cases rather than general assumptions about user behavior. Yes, so of course, user-centered design ensures that the design solutions are driven by the user's goals and tasks, like we said earlier, because the designer tries to imagine the actual user rather than just generalizing. Therefore, the design is driven to ensuring that the user goals and tasks are prioritized. Then prototyping and testing, there's a lot of prototyping and a lot of testing in user-centered design so as to ensure that the final output is very easy to use and satisfying to the users. Then we also look at the role of UCD in human-computer interactions, and these are some of its roles. First of all, it enhances usability because it ensures that the interface between humans and computers is seamless by providing usability. This results in interfaces that are easy to learn and efficient to use. Then it also reduces errors and increases efficiency by designing systems with user workflows and mental models in mind. And therefore, it helps to reduce the number of errors users make and allows them to complete tasks more efficiently. Then it also improves accessibility by ensuring that interactive systems are designed with inclusivity in mind, providing access for people of all abilities. For example, the disabled, people with disabilities, and even those with any kinds of impairments, maybe be it physical, sensory, or any other. It also encourages innovation in a way that it often leads to development of innovative interfaces and technologies by focusing on how technology can better serve the users rather than focusing on trying to imagine that the users will adopt the technology. It focuses more on how the technology can actually serve what the users are able to attain. And then it also minimizes development risks in a way that early user involvement and interactive testing reduces the risk of creating products that fail to meet the user's needs. Because in the process of UCD, there is a lot of involvement of the final user in testing and imaginations, prototyping, and everything else. So there is less development risk because by the time the product is being produced, they're already interacting with the users rather than just assuming and then producing a product. Also enhances user satisfaction as the users find the systems intuitive, enjoyable, and aligned with their expectations, since they are also involved since they are the center of the design process and everything is aimed towards them. Then we'll move on to another question, which was saying that what are personas and how can they form the design process? And also provide an example. So we understand personas as fictional characters created to represent the different types of users who might interact with a product, system, or service. Based on user research, personas help designers understand the user needs, behaviors, the goals, the pain points, They serve as tools to humanize and communicate the diverse characteristics of target users, allowing the design team to keep the end users in mind throughout the development process. So the key elements of the persona, we have the name and the demographics. That is a fictional name. Then other demographics like maybe age, gender, background information that help you to personify the user. Then the goals and the needs. That is what the user aims to accomplish through the product or service. Frustrations and pain points. That is challenges or problems that the user faces that the design should address. Behavior and preferences. That is information on how the user interacts with similar products or technologies. Motivations. That is the reason that drive the user's decisions or what they base on to make their decisions and take actions. Scenarios, maybe a brief narrative describing how the user might interact with a product or the system in a specific context. So how the personas inform the design process. First of all, personas guide the design process by focusing the team's attention on specific needs, desires, and limitations of the real user's essentials. And this helps to ensure that the product is built with the right functionality and usability in mind. Therefore, it clarifies the user needs and goals. Then the personas also help to drive decision-making in a way that during discussions about features and functionality and any other choices, they are the preference point, and the team would always ask themselves questions like, for example, would this feature be helpful for our persona whom they created? They also hope to prioritize features based on the user's goals and pain points. Take, for instance, if a primary persona struggles with complex interfaces, simplicity and ease of use will be prioritized. Then they also hope to create empathy in the designers, because the designers can better empathize with the target audience by visualizing those personas as real users with different challenges. And this helps them to be more thoughtful in their designing. Then they also help to guide context and tone. They influence the design of the user interface, including the tone of the copy, visual elements, interactions, making the experience more relatable for the target audience. They also facilitate communication, as they are often shared with stakeholders and cross-functional teams to ensure that everyone has a shared understanding of who the users are. That is, maybe we might have different groups of designers working together, but different groups, then if we share the same persona, then we are able to understand and work together with the same goal. Then we take this example of a persona here with a name as Bulia Abigail, age 35, occupation is a marketing manager at a mid-sized firm. Then take proficiency, he has intermediate proficiency, located in Kampala, Uganda. And his device preferences, he primarily uses a laptop and smartphone. Then background, works in a fast-paced environment, takes survey and uses multiple devices daily, enjoys online shopping and social media. His goals are to manage multiple marketing campaigns efficiently, track performance metrics in real time, collaborate with her team and external partners on certain projects. Then what frustrates her? She finds it difficult to integrate. What frustrates him? He finds it difficult to integrate various marketing tools into one platform and spends too much time switching between different software to analyze data. Needs better visual dashboards, quickly understand campaign performance. Then his behaviors spends most of the time on digital tools like Google Analytics, HubSpot, and social media. Prefers social initiative interfaces and typically works during regular business hours, but often checks campaigns performance during her off hours. So this is our scenario. Say that Bulia is managing 3 simultaneous campaigns for different products. She needs a tool that helps her to see performance metrics at a glance, generate reports, and collaborate with her team members in real time. A centralized platform would significantly reduce the time she spends switching between various apps. So as the designers have created this persona, we can use the different information that we have to kind of relate and aim our design process to fulfill the needs of this particular person. So, how Uria's persona informs the design process? The design team would prioritize features like integrated analytics, dashboards, real-time collaboration tools, etc. to be able to fit to the needs and preferences of this persona here. And then the team would also focus on designing a clean, visual, intuitive interface with customizable dashboards, ensuring that she can easily track metrics and manage campaigns without getting overwhelmed by the amount of data. Then, since she checks campaigns during her off hours on the smartphone, the design maybe can be made a bit better. We can focus more on accessibility by ensuring that the mobile interface is seamless and offers the same core functionalities of the desktop version, so that if maybe she's trying to check up on her work during her free time, it is quite easy and doable. Move on to the next question, which was asking us to discuss the steps involved in interactive design process, including ideation, prototyping, and evaluation. So these are the steps involved in the interactive design process. We have ideation, we have prototyping, we have evaluation or testing, we have iteration, and we have launch and post-launch iteration. We break them down a little bit. We're going to start with ideation. Ideation is a creative stage where designers and stakeholders brainstorm ideas, generate concepts, and explore potential solutions to address user needs and problems. It is about coming up with a broad range of ideas without worrying about feasibility. The key activities here, there is user research, which involves conducting research, such as interviews, observations, etc. Then there's brainstorming, generating ideas with potential design solution out of like thinking about them and suggesting them. Then we have sketching and storyboarding, which is creating low fidelity sketches or boards or storyboards to visualize how different ideas might come to life. This helps to communicate design concepts quickly. Yeah. The goal of this step is to explore a wide range of possible solutions and approaches before narrowing them down to a few that will be developed further. Then we move on to the next step, which is prototyping. It's a phase where designers turn ideas into tangible presentations of the product or system. These prototypes can be low fidelity, simple sketches of wireframes, or high fidelity, depending on the stage of the design process. We have two types of prototypes. We have low fidelity prototypes and high fidelity prototypes. Low fidelity are simple sample sketches, wireframes that just focus on basic layout, navigation, and flow without too much detail. Then high fidelity, those that resemble the final product more closely in terms of appearance and functionality. These are created with software like Figma, Adobe. Yeah. So the key activities at this step are wireframing, interactive prototypes, and simulations. Wireframing is creating a visual blueprint, the interface, and showing the layout structure of the user interface elements. Then interactive prototyping is building clickable prototypes that simulate user interactions to test functionality and navigate the flows. Simulation is using more advanced prototypes that allow users to perform tasks and experience the products in a realistic setting. The goal of prototyping is to build a prototype that can be tested with users, hence allowing the designers to gather feedback about functionality, usability, and the overall user experience. Then move on to evaluation or testing. And this step involves testing the prototype with real users, the prototype that we created in the previous stage, to gather feedback and identify issues relating to usability, performance, or other aspects of the design. The aim is to validate assumption, uncover pain points, and gain insights into how the users interact with the product. The key activities here, there is usability testing, which is observing how the users complete tasks with the prototype, and this can help you to identify issues in like navigation or maybe task flow and many others. Then we have A/B testing, which is presenting users with two different versions of the product to determine which one performs better based on specific metrics, for example, conversion metrics or user satisfaction. Then we also have heuristic evaluation, and having usability experts review the design based on usability principles to identify potential usability issues. That's how I simply understand what heuristic evaluation is. Then we also have surveys and interviews, which help to collect feedback from the users, questioning them about the features of the prototype and what they think about it. This can help create a deeper insight of what they want, what the users want, and what they do not want. The goal of this stage is to gather actionable feedback that informs the next iteration, the next part of the design process. Then the findings from the evaluation phase, they guide improvement and adjustment to the design. Then we move on to iteration. So after evaluating the prototype, the design team revisit the drawing board to refine and improve the design based on the feedback they have collected. This process of iterating, designing, prototyping, testing, and refining continues until the product meets the needs of the user and it is optimized for usability and performance. That is the iteration step. In this step, the key activities include incorporating feedback, that is analyzing the feedback from the evaluation step and making changes to address the issues. Then refining the design, that is updating the prototype by adjusting layouts, improving functionality, and modifying based on the insights we gathered from the evaluation stage. And then we test again. The updated design, we test it again with the users, and the process keeps repeating until the design reaches the desired level by the users. The goal here is to progressively improve the design through repeated testing and refinement cycles, ensuring that the final product is user-centered, functional, and it meets the intended goals. Then we move on to the last stage, which is launch and post-launch iteration. So once the design has gone through the several iterations and meets the necessary qualities and usability standards, the product is ready to be launched. However, iteration does not stop there. User feedback after launch can lead to further refinements and adjustments. So key activities here, we have beta testing, which is releasing the product to a limited group to gather their feedback before the final launch or the full launch. Then we have post-launch monitoring, which is collecting data from real users interacting with the product post-launch through analytics, feedbacks, forms, and customer support inquiries. I think that stage goes on for a very long time. Then continuing improvement, which is making updates and improvement based on the ongoing user feedback. Yeah, so the design does not stop after you are released. Keep on updating, as we have seen very many businesses and organizations do it. Take, for example, the telecommunication companies, they keep asking about their products and then they keep adding more features. So the goal of launch of this stage, this step of launch and post-launch iteration, is to maintain and enhance the product even after it has been launched, ensuring it continues to meet the evolving user needs and expectations. Yeah, so I think we move on. Move on to the next. We move on to the next question, which was asking us, so we move on to how the user-centered design can be used to improve the usability of a product or the services. So we have a few points here of how user-centered design is used in improvement of products. So we shall go through them one by one. First of all, it helps to understand user needs and contexts. So first of all, it begins with in-depth user research to understand what the users are and what their goals are, the context in which they have to use the product. And this helps the designers to build a product that fits into the user workflows and real-world scenarios. Then the personas and scenarios help in creating designs that are based on the personas that were created And these scenarios help to illustrate how different users will interact with the products, showing that the design considers a variety of use cases. Then, secondly, user-centered design also involves users in the design process. So in ways, for example, through interactive feedback and collaborative design, and interactive feedback in the multiple stages of design process ensures that the feedback that is gathered early and often is used to identify usability problems before the product is fully developed. Then collaborative design helps the team to refine features and interactive flows based on the input that they get from users through co-design sessions and workshops and so on. Then prioritizing usability and accessibility helps also in improving the usability of a product in a way that focus is put on making the product simple and very clear and also accessible. Simple and clear in a way that the interfaces are simple, intuitive, and easy to navigate, and accessible in a way that they cater for diverse groups of people, including those with impairments and maybe disabilities. Then it also helps in reducing errors and cognitive load in a way that it strives to reduce the user errors by designing interfaces that are clear and predictable. So when errors do occur, the system should provide useful error messages and the easy ways for users to recover. Then we also have prototyping and testing early, which helps to review the design based on usability principles and to identify the potential usability issues. And then we also have surveys and interviews, which are also part of prototyping and testing, where we collect qualitative feedback from the users after they interact with their prototype. And this helps to provide a deeper insight into the user preferences and frustrations. So when we create these different prototypes and we test them, it helps to ensure that the design is validated and it is optimized. Then we also have iterative improvement, that is continuous refinement and real-world testing. So when we test in the real world, we identify issues that may not surface in the controlled environment, such as unforeseen user behavior and performance problems. And then this continuous refinement ensures that the product continuously evolves and improves over time, leading to better usability with each cycle as the designers keep on improving the usability to fit the current situations. And lastly, focuses on user satisfaction. Therefore, the designers have a lot of empathy and they engage with the users a lot in the design process. And therefore, it increases user loyalty and long-term use, and also ensures that the designers are able to meet the emotional needs of the users and hence reducing frustration. Then we move on to the next question, which was saying, how does the concept of affordance relate to human-computer interaction and UX design? So affordance, as introduced by the psychologist James J. Gibson, it refers to the relationship between an object's properties and the capabilities of the user, which together determine how the object can be used. In design, affordance is perceived, and in design, it is the perceived and actual properties of an object or interface that indicate how it can be interacted with. We have 4 types of affordance. We have perceived affordance, we have actual affordance, we have hidden affordance, we have false affordance, and negative affordance. Then we're going to look at how affordance relates to human-computer interaction and UX design. So first of all, it helps in supporting the user expectations. How does it do that? It does it like this. Affordance helps to meet user expectations by making interactions predictable and intuitive. When affordances are aligned with familiar conventions, users can quickly figure out how to use the system, and hence reducing their cognitive load and the learning curve. Take, for example, the trash can icon file management app affords the idea of deleting files because users recognize it, because the trash can is what is used in normal life to represent deleting or omitting. Then creating usable interfaces. UX designers are UX designers usually use affordance to create interfaces that are easy to navigate and interact with by signaling what users can do. Whether it is tapping, switching, clicking, or dragging, affordance minimizes confusion and helps users to complete tasks with ease. For example, in a mobile app, buttons that resemble real-world controls, for example, switches or sliders, offer clear affordance that offer guidance on users on how to interact with them. Take, for example, in an app which has a button that has a dark mode, and there is a button that when you click it and it turns to the side and light screen, then that dark mode turns on. It is better as opposed to, say, for example, a user having to adjust something so as to be able to, to turn on the dark mode, because the user can easily know that this is a button that when I turn on, dark mode will turn on. Then visual affordance in user, visual affordance in user interface design. In visual design, affordance really relies heavily on cues like color, shape, size, and positioning. Designers make buttons look clickable, text fields appear typable, and links seem tappable by manipulating these visual elements. Then, affordances in navigation. Effective use of affordance in navigation design can guide users through a website or app effortlessly. Clear affordances like drop-down menus or permission controls tell users how to navigate the site and where they can go. For example, pagination buttons at the bottom of a search result page afford the ability to go to the next set of results. The next button is usually more prominent to make the action clear. For example, on Google Chrome at the extreme bottom, there is that one that says next. The user knows that if I click next, they're going to bring me another set of results. Yeah, so we look at how affordance improves. Let's talk a little about affordance and usability. Effective use of affordance in UX design. Effective use of affordance in UX design can dramatically improve usability by making interaction intuitive and easy to understand. Poor affordance design, on the other hand, can result in frustration, confusion, and errors. So, how does affordance improve usability? It reduces the learning curve. When affordance matches the user expectations, the interface becomes easier to learn. For example, using familiar icons and buttons. Then it also helps to minimize errors, as affordance helps users understand what actions are possible and prevent them from attempting things that are not possible. It also enhances efficiency by clearly signaling how interaction should occur. Then affordance also allows users to complete tasks quickly and also increases satisfaction, in that when a user can interact with the product seamlessly and without confusion, the overall satisfaction with the product improves, and that enhances user engagement and loyalty. Then we move on to the next question, which was asking us to talk about some of the common user-centered design methods. So there are very many user-centered design methods, and therefore we're going to talk about them very briefly. So we have user research, which is the foundation of user-centered design, as it helps designers to understand the target audience needs, the goals, behaviors, and the pain points. This research is carried out in very many different techniques, and these include interviews, surveys, field studies, and maybe focus groups. Maybe to throw more light on focus groups, this is where they facilitate group discussions to gather opinions, attitudes, and insights from multiple users simultaneously. Then we have personas, who we talked about earlier, who are fictional characters that represent different types of users who might interact with the product. They are created based on user research data that is gathered in the user research method, and they encapsulate key characteristics, goals, frustrations, and behaviors of the target audience. Yeah. For example, our previous persona who we talked about, Abigail. Then we have journey mapping, which is a visual representation of the steps a user takes while interacting with a product or a service. It highlights the key touch points, the emotions, pain points, and opportunities of improvement. And its main purpose is to visualize the user's end experience with a product and to identify where users encounter problems or maybe any kinds of frustrations. Then we also have wireframing. So wireframes are low fidelity visual representations of a product and the layout structure. They focus on the arrangement of content and functionality on a page without delving into detailed design elements like color schemes or images. Their purpose is to provide a blueprint of the interface, showing how different elements will be organized and how the navigation will flow. Then we also have prototyping, which also talked about earlier, which involves creating interactive mockups of the product at various levels of fidelity. And it also allows users to interact with the design and provide feedback. Then we also have usability testing, which is a method of evaluating how easy and intuitive a product is to use by having real users perform specific tasks. We observe the users, and this helps the designers to identify the problems, frustrations, or inefficiencies. Then we also have heuristic evaluation, and this involves having usability experts review the product interface based on a set principle, which is known as heuristics. Then we have card sorting, which is a method used to understand how users categorize and organize content. Users are asked to group items, which are represented by cards, based on how they think the content should be structured. And this helps to inform the information architecture of a website or the app, ensuring that the navigation and menu align with the user expectations. Then we also have affinity diagramming, which involves organizing and clustering qualitative data, such as user research findings, into groups based on patterns or themes. It helps the design team sympathize insights and identify common problems or user goals. And its purpose is to make sense of the large amounts of data that we have gained from the user research. We also have contextual inquiry, and this is where researchers observe and interview users in their actual environments while they interact with the product or perform tasks related to the product. It helps to gain deep insights into how users work and the challenges they face in the real world, and also to observe the workflows, the tools, the environmental factors that impact how users interact with the system. Lastly, we have A/B testing, which is used to compare two versions of a product or feature to determine which one performs better based on the user behavior or the predefined metrics. It helps to test different designs or features to optimize conversations, engagement, and satisfaction, and to make data-driven decisions about which version of a design is more effective. That is all from this question 2, which was discussing user-centered design.
Hello, I'm Tumoske Ibrahim, and I'm taking you through task analysis. Task analysis is basically the process of breaking down a complex task into smaller and more manageable subtasks, and it involves examining the steps, decisions, goals, and challenges users encounter while completing a task. Simply, in simple terms, designers look at several aspects and break down the tasks a user is supposed to complete into a number of subtasks, and then these subtasks is what the designer is based on to create interfaces for a given system. Why is it essential for task analysis and user-centered design? One is to understand user workflows. Here we mean task analysis is essential in such a way that it will help the designer to know how different steps or how different tasks follow each other when performing a given task or a given complex task. And then identifying pain points. This looks at basically the difficulties or the I would say the challenges that are involved in user-centered design. Also improving usability. Usability is basically how the users interact with the system or the product that the designer is creating or has created, and also prioritizing features of creating user-centered workflows. This basically means we look at the designers look at steps that users are more conversant with or that suit the users needs, supporting diverse needs. This goes hand in hand with the one before. Optimizing task efficiency. Then next is yes, these are the types of task analysis. To begin with, hierarchical task analysis (HTA). This involves breaking down a task into hierarchy of subtasks. This means a given task is divided or broken down into a number of subtasks. However, they are broken down in a given hierarchy. The order of hierarchy depends on from the most general to the most specific. Then we have cognitive task analysis, which is CTA. This basically looks at the mental processes involved in completing a given task. Some of the issues we look at is the decision-making level of an individual, of the user, the perception of the individual, the memory of the user. Also, we have procedure task analysis, which involves identifying the step-by-step procedures a user undertakes or follows to complete a given task. We have GOMS analysis. This is basically for goals, operators, methods, and the selected rules. That's to say, this type of task analysis basically looks at the goals a user wants to achieve, and so on. Then the actions or operations that he undertakes to complete the goals or to achieve the goals. Then we have the method the user will use to accomplish the tasks, and then the selection rules or the decision point, the decisions he takes to complete that or that determine the method to use in order to accomplish or achieve that goal. Then we have keystroke. stroke level model. This is more detailed and more specific form of GOMS. Okay, it's more detailed of the one, or the one that depends on the goals, operators, and methods, and selection rules. It breaks down into the individual strokes and mouse and actions required to complete them. Okay, for this one, we go into details of the goals, of the operations or tasks. We go into detail at the methods and also the selection points, the selection rules. Sorry. We also have contextual task analysis. This involves observing users in their natural environment as they perform a given as they perform the tasks. Now the factors that affect the environment, the physical environment, are the ones that the users base on, the designers base on to design a system or a product. Also, we also have a social task analysis. Social task analysis, this basically looks at the social and collaborative context of the tasks that are being complete now, or that are to be done by the users, and these collaborative or social tasks are the main aspects that are followed when designing for the user interface. Then last but not least, we have ethnographic task analysis. This involves studying the users in their natural environment over a long period of time to get rich and more efficient information about a given task, about how they perform a given task. Take an instance of maybe shopping. Okay, there is a way everyone does his shopping. One may maybe take an Uber, go into the market, and then look for the items they want, move around, and then come back home after paying, maybe something like that. Another individual may also do online shopping, where he might also opt to do a delivery. The product might be delivered to the home address or to a given point where the user is capable of coming to pick it him or herself. This is also another way of shopping. Then, as you follow these trends of how different users do a given task, you're capable of designing a system or product that suits all of them. Next is the differences between hierarchical tasks, HTA and CTA. As we earlier said, HTA looks at the task decomposition and structure. Okay, the structure is basically the hierarchy of the subtasks, then cognitive processes and mental models. As we earlier said, CTA basically looks at the mental processes of the tasks, or how the users handle a given task mentally, and then also understanding how tasks are broken down and are organized. Yes, then we have how in CTA we have explore, how users think and solve problems. That's basically the mental processes, as we earlier said. Here in high HTA, we have creates a hierarchy of tasks and subtasks. Okay, then we have analyzing the mental processes involved in the task process of task performance. Here we have already looked at it in the description of CTA. Here, okay, in HTA, maybe what I didn't mention, we have task diagrams, flowcharts, and task lists. Since we said we are following it in a given hierarchy, so we can also do task diagrams. However, for CTA, we have detailed cognitive models, think aloud protocols, which involves basically looking at how users think in order to perform a given task. Also, we have in HTA, we have used to design systems constructing tasks and flows. And then for this side, we're looking at using improve systems by understanding cognitive demands. Okay. To continue, when would we choose HTA over CTA? CTA would be chosen first when the task involves well-defined steps and is relatively straightforward. Now, for this one, we would take it when the task is in a given order, in given steps that have hierarchies. We are not leaving behind the concept of a given hierarchy. Then we also, when you need to understand the sequence and the structure of actions users must take to complete a task. Now, for this one, we mean when you need to understand in which order are particular tasks handled. For example, as I said in shopping, which do you pay first before you go to the app, or you go to the app first and then you pay? So that sequence, when you need, if at all you need to know that sequence, HTA would be the best over CTA. And then also when the task is physical or routine in nature, the goal is streamline and improve the efficiency of the task's flow. So if the task is also in a routine in nature or physical in nature, HTA would be the best option than CTA. Maybe to add on that, if at all the task is more complex, okay, we would also prefer that. And then why would we choose CTA over HTA? When the task involves significant mental processing and decision making. Okay, if at all you have the system you're creating involves making a decision or problem solving, CTA would be the best option to choose over HTA. Okay, also when you want to understand the challenges users face when performing the task, such as information gathering or decision making, we would rather choose CTA that takes on the mental procedures of the user other than HTA. Also, we would choose CTA when the task occurs in a high stakes or expert environment where errors due to cognitive overload or poor decision making could have serious consequences. Okay, for this we mean if at all the the tasks we're handling, if at all, maybe the decision making on a given task would create a serious consequence due to poor decision making, we would rather choose CTA other than HTA. Okay. Next is how task analysis is used in improving usability of a product. This is we would use task analysis through understanding the user goals and needs. When user needs and goals are really understood, we would improve greatly the usability of the product. We have also identifying inefficiencies of task flows. Okay, here if at all we happen to understand the inefficiencies of how processes follow each other or how tasks are performed in a given sequence, then here we would improve the usability of a product. So say if at all you would pay for a product before even selecting it, or before you identify the product, it wouldn't make sense. So if at all this order is in a chronological sequence and you put them in a design, then the usability of the product, I'm very sure it would be much improved. Then how discovering pain points. This looks at basically the loopholes into all the challenges that are within the design, or the loopholes that are within task performance. We have also designing different user levels. We have streaming task sequences. We have optimizing the context and environment, or reducing cognitive load. Cognitive load is basically in decision making and the mental processes. If we happen to reduce that would improve the usability. If we have prioritizing features enhancements, supporting error recovery and prevention. This looks at when doing task analysis, or through doing task analysis, we can incorporate in error recovery and prevention, which would greatly improve usability in such a way that a user is more certain that in case of an error, he can recover the data or the tasks, and then also there is a possibility of prevention to an error. We have creating tailored user experiences. Then task model concept. What is a task model concept? This is basically a structured representation of tasks and goals that users perform when interacting with the system. It is basically the breakdown of complex tasks into simple, manageable, and provides a framework for understanding user behavior, decision making, and interaction patterns. What this deals with is basically to break down complex tasks into simpler steps or simpler subtasks, and then also you put them in a given framework that would suit the user's mental processes and how simply a user would interact with the process. The main purpose as to why we would do this is to help the designer understand the goals and processes, user's flow, ensure. This basically deals with how users do a given task and whether the system meets their needs. It would be of no use you creating a system and the user interacting with it it does not satisfy his or her needs to the maximum, in that he does not get what exactly he opted or he thought would be out of or a benefit of the system. Okay, then it will also, the purpose is also it assists in testing whether the system effectively supports the intended test. That's in the explanation I've just raised in the previous point. Next is the components of the task model. So a task model is divided into a number of components. That's the tasks, which are the high level goals or the high level tasks. That the main task we're looking at, that is going to be broken down into smaller subtasks, and then the other component is the subtasks itself that come from the main task. Then we have the actions. These are the specific specific interactions, like the operations that are performed by the user to complete these specific tasks or specific subtasks. Then we have conditions. These are the circumstances that affect task performance. We have decision points. These are the places where users need to make a choice, like selecting an option or deciding to proceed. Okay. Next is the example. Okay, I have an example of a task model. Here I have highlighted the key points. Okay, the components that are involved in a task model with a real life example. I'm using an online shopping system. What is the main task here? Is purchasing a product online, and if that is the main task, if we divide or if we break down this main task into a number of subtasks, we would have one, searching for product. When you visit the product line, you would search for product you need, view the product details, add the product into the cart, proceed to the checkout, enter shipping and payment details, and confirm purchase. These are the subtasks that would be involved in purchasing a product online. And then the operators is clicking on the search bar, that is for the search for a product, and then type keywords. Then also select the product from the list, that would be the viewing of the products. These are the operation or the actions you take for you to complete a given subtask. Then the decision points will be choosing between different products or confirming correct the delivery addresses or delivery information. Next is task analysis methods. These basically look at the methods you use in order to perform task analysis, and these are basically determined according to the type of task analysis you're using, and also it would also depend on what is the main task what is the complexity of the task you're handling, or that you're going to analyze. Some of these task analysis methods are HTA, we have CTA, we have GOMS, ethnography, workflow analysis, user scenario analysis. These are basically the task analysis methods. And to continue, we have the challenges of conducting task analysis. These are the challenges that would be faced in task analysis when conducting task analysis. One is complexity of task analysis. Complexity. We have time for complexity of task analysis. We have complexity of the tasks. This is when really the task you're looking at or you're analyzing is really hard, and it is very difficult for you the designer to break it down into a number of subtasks. We have time consuming, as we all know that breaking down one big or one complex task into a number of subtasks and then look at every aspect of every subtask, that is really time consuming. Then we have the cognitive processes are difficult to capture. That is looking at the mental processes involved in task performance, say decision making. It's really to capture that. Then variable in user behavior. So for the mental decision making, you wouldn't say that when I'm going to shop that I'm supposed to look for this. No. I might opt to go there physically. I would okay, users basically have different behaviors, so you can't put into consideration everyone's behavior into the system. Then you have inaccurate and incorrect data collection. Yeah, at times we have inaccurate data based on when designing. We have resistance from users, which would create maybe privacy issues, privacy concerns. We have difficulty in translating results into design. Yes, for this, here we would say that it is really, really, really difficult to say that this is what I have got and let me put it into design. Okay, let me start designing after what I've got. Okay, you might find it very difficult. Okay, the results that you have gotten might be very difficult for you to turn it into the designing bit, as I may say that you can't choose someone this. Okay, you can't choose to say that I'm going to design such and such a system that is going to be taken into this consideration. You might find that a given user wouldn't prefer taking that, which would create a confusion in the design. Okay, yeah, this is a real world task analysis. Okay, we have ordering food through a food application. Some of the task analysis we will go through is define the real goal, what the goal is, which would maybe ordering for food or buying food. Then the other would be breaking down the tasks into high level tasks. Then we would break down the high level task into the sub task. Okay, then identify the possible errors or decision points, which we call the pain points. Then prioritize the steps that need improvement. Okay, thank you for now.
Hi everyone. My name is Namakula Josephine and I'm starting from where my colleague has stopped, and I'm starting with interaction design. First of all, what is interaction design? So interaction design is a critical component. I'm starting with interaction design, and why is it a critical component of user-centered design? So interaction design refers to the process of designing interactive products and facilitate the way people communicate, work, and interact in both everyday and professional contexts. It focuses on creating user experiences that enhance and augment these interactions. So considering how users behave, reacting, and communicate in different environments, interaction design encompasses a range of methods and approaches aimed at designing meaningful user experiences. So why is it a critical component in user-centered design? Because it focuses on user experience, it enhances usability, it improves accessibility, it supports engagement, context sensitivity, and it guides user journeys. So joint focus on user experience. Here, we like interaction designers define how users should interact with the product, while focus on user experience. Like interaction designer, like it is user-centered, emphasizing how users interact with the product and ensuring the experience is seamless and enjoyable. So with the product, second, it enhances usability, where it ensures that the product is easy to use and aligns with how users manually think and behave, which minimizes errors and improves on the feedback. So it improves accessibility by considering different user abilities and contexts. Interaction design like makes digital products more accessible and inclusive. So it supports engagement, because it fosters user, because it like supports engagement by making interactions smoother and more rewarding, leading to increased user satisfaction and retention. So there is context sensitivity, in which users operate, adopting experiences to different devices, environments, and user needs. It guides the user journey, where it defines how users navigate through an application or website, ensuring a logical flow of actions and clear pathways to goals. So when I go to the next slide, I find the key principles of interaction design. We have visibility, where important functions should be visible and easily accessible to users, making it clear what actions are possible. For example, buttons, menus, should be easy to find and understood. There is feedback. Feedback is a very critical component because the system, the system should provide immediate feedback to users about the actions they have taken. This helps them to understand the outcomes of their actions with the system and guide them on what they should do next. There is constraints. Design should limit user actions to prevent errors. So this can be done by disabling certain options or showing only the actions that are relevant at a particular user at that particular time. So consistency, like the interfaces should be designed in a consistent manner, making it clear to learn to use. For example, similar operations should be achieved using the same methods throughout the interface. There is affordance. The design should make it clear how to interact with an element. For example, buttons should look clickable, and the handles should look like they can be pulled or grasped. So when I go to the next slide, I find the differences between interaction design and user interface design. So interaction design is concerned with creating seamless and meaningful experiences for users when they interact with a system, focusing on how users interact with the product. So it focuses on designing the flows and behaviors that make the interaction between a user and the system smooth and intuitive. So while in user interface design, for it is to create interfaces that are not only visually appealing, but also intuitive, user-friendly, and conducive to a positive user experience. Like the word user interface design is self-explanatory. Okay, so how do these collaborate in the development of digital products? Who do we mean that What do we mean? Who collaborate in this way? So here we are talking about interaction designers and UI designers. How do they collaborate? So there is joint focus on usability. So here interaction designers define how the user should interact with the product, while UI designers ensure that the interaction are visually intuitive. So they both prioritize creating an easy and enjoyable product. So there is workflow integration. Interaction designers map out to user flow, define user journeys, and focus on functionality. They define how different elements of the product will work together. While UI designers take this structure and create the visual interface, ensuring that users can intuitively understand and interact with it. So there is iterative process. Both fields work together in a cylindrical design process. So after interaction designers prototype a flow, UI designers create the visuals, and then both teams test the product with users. So based on this feedback, they refine the interactions and visuals for the better usability experience. So there is alignment of goals. Interaction designers ensure that the design is user-centered and functions and function the design is user-centered, functional, and intuitive. So while UI designers make it attractive and aligned with the brand image, but they also ensure that the visual design supports ease of use and interaction. So what are the interaction design methods and the technique? We have user research, sketching and prototyping, wireframing and mockups, design patterns and principles, and user testing evaluation. So in user research, user research. So first of all, before someone is going to do anything like designing, starting up something new, you first have to carry out user research to gain what the users want. What will you be doing? What exactly will you be doing? To get even to gain insights on more insights on that thing you are going to be introducing. So user research, it forms the basis of interaction design by providing valuable insights to users challenges, motivations, preferences, and expectations. So this research can be conducted through methods like interviews, there is data analysis, focus groups. So it aids in identifying user needs, it like pain points and objectives. So while revealing opportunities and obstacles in the design process. So additionally, user research helps in creating personas, user journeys, and scenarios, which are essential for understanding users effectively, conveying the design vision. So prototyping and sketching. So these are critical components in interaction design that enable rapid and cost-effective exploration of various ideas and concepts. Sketching, a low fidelity method, involves creating basic and informal drawings of the interface, functionality, and flow. So this approach helps in brainstorming, sharing ideas, and gathering feedback from stakeholders and users. So on the other hand, prototyping is a user-friendly technique that involves developing interactive and detailed methods of the design. So it aids it aids in how functions will be working in the system from which page to the other page, and all those can be done in using there is some open softwares you can use to design prototypes. You can use Adobe, you can use Figma, you can use Photoshop, you can use Canva to design prototypes of a certain product you are going to build. So this aids in assessing and fine-tuning the design while evaluating its usability, visibility, and appeal. So there is wireframing and mockups. So wireframing and mockups are interaction design techniques that helps someone to design and visualize the structure, layout, and content of the interface. So wireframing is a technique that involves creating semantic and the abstract representations of an interface. So using boxes, lines, placeholders. So wireframing can help us organize and prioritize the information, navigation, and functionality of the interface, as well as establish the hierarchy and relationship between elements. So mockups, on the other hand, is a technique that involves creating realistic and detailed representations of an interface using colors, fonts, images, and icons. Mockups helps us to define and refine visual styles, aesthetics, and branding of the interface, as well as convey the look and feel of the design. So we have design patterns and principles. These are the techniques in interaction design that ensure interactions are consistent and intuitive, aligning with user expectations and needs. We have user testing and evaluation. So after designing the product, it is taken to users for to get feedbacks from them. Yeah. So it mainly focuses on assessing and enhancing the quality and the performance of the design. So user testing involves observing and gathering data from actual or potential users as they interact with the design using methods like task analysis. So task analysis. So think aloud protocols and eye tracking. So this process helps uncover and address usability issues while validating and refining the design. So in evaluation on the other hand, it involves analyzing the data collected during user testing, through various metrics such as completion rates, LR rates, user satisfaction, and time spent on the tasks, user fascias, how user fascias. Okay, like body language, it can also be assessed. When I move to the next slide, I find designing and we were told how would you design a user interface for a new mobile app that allows users to track their fitness goals. First, we define objectives and user needs. We create user personas. Who are user personas? So developing personas based on user research. We find we would create personas representing different types of users, such as beginners, experienced athletes, all those with specific fitness goals. So we design the user journey, we map user flows, outlining the typical journey a user might take within the app, from setting up their profile to tracking progress and viewing achievements. There is wireframing and prototyping. Create low fidelity frames to establish the layout and structure of his screens. We design the visual interface, create the color scheme, select motivating colors that align with fitness themes, such as energetic and vibrant hues. The prototyping part, use readable fonts with varying weights to highlight important information and ensure legibility. There is designing the visual interface. Yeah, sorry, I've repeated that. There's implementing key design patterns, focus on usability, testing and iteration. There is also launching and monitor to ensure that the app is really working as expected. We have types of user interfaces. We have graphical user interface, voice user interfaces, gesture-based interfaces, natural user interfaces. There is text-based interfaces, command line interfaces. So for the graphical user experience, this is the type of user experiences which use visual elements such as windows, icons, buttons, and menus, and interaction is primarily through direct manipulation of these graphical elements. So the example here, we can have desktop applications, mobile applications, web applications. So the voice user interfaces, like this is the interaction through spoken commands and responses. So no visual interface is required. Instead, feedback is auditory. So the examples we have like virtual assistants like Amazon Alexa, Google Assistant. You also have voice controlled devices. So here we have gesture-based interfaces, interaction through physical gestures such as swipes, taps, pinches, and hand movements. We have touch screens, we have motion sensing devices, we have gesture control smartwatches. So we also have natural user interfaces, interaction in immersive control environments that simulate real world interactions, often using spatial and environmental context. We have augmented reality, we have virtual reality environment. This is mainly in simulations and modelings. So text-based interfaces, this is the interaction through textual input and output. So commands and responses are text-based. Like examples have command line interfaces, chatbots. So the interaction consideration here, like command clarity, like you design commands and responses to be clear and ambiguous. So the user guide provide helpful prompts and error messages to guide users. So the command line interfaces is a text-based where users type commands to interact with the system. So it is common in technical environments like programming or systems administration. So the example here, we have Linux terminal, where users, like every time they enter text command to execute a task. So on the next slide, we are told to define the significance of feedback in interaction design, feedback and feed forward. The significance of feedback and feed forward in interaction design systems. So first of all, I'm starting with the significance of feedback in interaction system. Like it clarifies user actions where like feedback reassures users that their input, like clicking a button, was recognized, like avoiding confusion. There is error prevention and correction. When users make a mistake, feedback helps them understand what went wrong and how to fix it. So it guides users through processes. It helps users proceed smoothly through a sequence of actions by indicating what has been done and what's next. It builds trust. Continuous and clear feedback builds user confidence in a system, making them more likely to use it effectively. So the significance of feed forward in interaction design. Feed forward prevents mistake by showing what will happen. Users can make informed decisions, reducing the chance of errors. It improves efficiency, where it reduces cognitive load by guiding users, making the interface more intuitive and actions easier to understand. It enhances user confidence, knowing what to expect, encourages user to explore and interact with a system. So in brief, like feedback refers to the response users receive from the system after performing an action. So it also confirms whether their actions were successful or not and helps users understand the system's current state. So the feed forward refers to the system providing users with guidance and hints on what will happen before they interact with the system. So it helps users understand the effects of an action before they take them. like it is like a user manual. The feed forward is like a user manual. So how do we ensure clear and meaningful feedback? Immediate and timely feedback, like immediate and timely feedback. Here, the feedback should occur as soon as the user acts. So delayed feedback can confuse and frustrate users. For example, after clicking or like submitting on a form, users should consistently see a successful message or an indication that a certain action has been taken. So there is clear and understandable feedback, where feedback should be easy to understand and it is appropriate to the context. So users should know what went wrong without like needing to decode the feedback. Correct, like instead of like a vague error message like over error 44, like we should use a clear language like page not found, because not everyone like understand those codes. There is consistent feedback across the system, like to maintain user expectations, like appropriate feedback channels. We have to use the right type of feedback, like visual, auditory, or haptic, like based on the action performed by the user's environment. Error messages with constructive feedback, which involves an error, like if the feedback involves an error, we have to provide a message that not only describes the error but also offers a solution on next steps. Like there is also balance of feedback, like we do not have to overwhelm users with too much feedback. Like sometimes it can bias them or it can become distracting or annoying. So on the next slide, we have the role of wireframing and prototyping in interaction design. So first of all, the role of wireframing in interactive design, there is cost effectiveness and quickness. First, there is also like it simplifies and defines features. It improves communication. It enhances project precision. It is time saving and guides website compliance. As we said, like wireframing is the process of creating a low fidelity visual representation of an interface, and prototype is the process of creating a preliminary version of a sample of a final product that designers use to test and refine before the actual launch. So the cost effectiveness, so it means that they are not expensive. The wireframes, sorry, the wireframes are not expensive and they are quick to create, allowing for rapid interactions. They simplify and define features, where they help in defining and simplify features of a website's app, ensuring that the focus remains on functionality and user experiences. It improves communication, where it makes it easier to communicate design ideas to clients. It also enhances project precision by providing a clear blueprint. So wireframes bring precision to the project, helping to avoid misunderstandings and ensuring that everyone is on the same page. It is time saving, where it helps to streamline the design process. It's saving time by defining potential issues early on. It guides website compliance by deciding website compliance with design standards and user expectations. So the role of prototyping saves money and time, because because it allows teams to identify and fix issues are in the design process, and it also like does not involve a lot of code. It does not involve code at all. I cannot say lot of code, does not involve code at all. So designing it with different elements using the different softwares, it's easy to create and time consuming and time saving. Sorry. So it simplifies workflow by providing clear and visual representation of the designs. So it simplifies it makes it easier for teams to understand and aligns with the project's objectives. Like also prototype serves as a visual communication tool that helps align teams, ensuring that everyone involved in the project shares the same vision and understanding the product design functionality. Increases conversion rates, identifies bugs early, enhances user involvement. So wireframing and prototyping helps in how they help in the early design exploration and user testing. So early design explorations, like in early design exploration, there is wireframe support, there is like wireframes as no. So how wireframes and prototyping help in the early design exploration and user testing? First of all, we have early design explorations where wireframes support brainstorming. Yeah, it's wireframe supports brainstorming, which facilitates the rapid iteration by enabling designers to explore different layouts, content arrangement, and navigation flows without focusing on visual design details. So prototypes support like interaction discovery, where they go a step further by simulating user interactions, helping designers explore how users will engage with the systems. So it visualizes concepts by like both of them allow teams to visualize abstract ideas. There is reducing complexity by breaking down complex designs into simple wireframes and prototypes. Designers can tackle one problem at a time, ensuring that the system is easy to understand and use. So, when I go to the next slide, I find question 5, which is about usability and evaluation. So, when I go to the next slide, first of all, I'm going to define what is usability and I give its components. So usability refers to how easily and effectively a user can interact with a product, system, or interface to achieve their goals. It is a core principle of interaction design and user experience design. So focusing on creating systems that are intuitive and easy to use, sorry, usability ensures that users can perform tasks without frustration, confusion, or unnecessary effort. So the components, we have effectiveness, efficiency, and satisfaction. So effectiveness like measures the ability of users to successfully complete tests using that system. So it is concerned with whether users can achieve their goals accurately and comprehensively. So efficiency, like this refers to the speed and resourcefulness with which users can complete tests. It measures how quickly users can achieve their goals with minimal wasted effort or time. So the satisfaction, it is the degree to which users feel content, comfortable, and pleased with the experience when interacting with a system. So it is subjective but crucial for ensuring user retention and positive engagement. Three principles of usability. We have learnability, like how easy it is for users to accomplish a task based on the first time they encounter with the system. There is efficiency, which ensures how quickly users can perform tasks after they have learned the system. There is memorability, which focuses on how easy is it for users to re-establish proficiency after returning to the system. There is error prevention and handling. So this principle addresses how well the system prevents errors and helps users recover from mistakes. There is satisfaction, which refers to how pleasant and enjoyable it is to use the system. There is accessibility. There is feedback. Like accessibility ensures that the system can be used by people with a wide range of abilities and disabilities. Flexibility, like a flexible system, it accommodates different user needs and preferences. How can usability be measured? It can be measured through effectiveness, efficiency, satisfaction, learnability, memorability, errors, cognitive load, and accessibility. The types of user testing, we have moderated user testing, unmoderated user testing, remote usability testing, in-person usability testing, formative user testing, summative user testing, qualitative usability testing, quantitative usability testing, A/B testing, eye tracking usability testing, guerrilla usability testing, holistic evaluation, and cognitive walkthrough. So the holistic the next slide, I found holistic evaluation and how it is assessed. So holistic evaluation is the usability inspection methods where a small group of usability experts evaluates an interface against a predefined set of usability principles known as heuristics. So these heuristics act as general guidelines or best practices in human-computer interactions designed to identify usability issues within a system or a product. So how is it assessed? Like first of all, experts can review the interfaces. Like usability problems can also be identified. That's yeah, you can also assess it into like usability problems being identified. You assign severity testing. There is also recommendation for improvement. Yeah. So what do we mean by experts review like experts review the interfaces? So so experts review the interface, like a small group of usability experts evaluating the system based on holistics like visibility of system status, error prevention, and consistency. So usability problems identified here, the experts walk through the system and find where it violates these usability heuristics, highlighting issues like poor feedback, confusing navigation, or inefficient workflows. They can also assign severity ratings to each identified problem given. So to each identifying problem, they can give it a rating, like from minor to critical, to prioritize fixing the most impactful issues. There are also recommendations for improvement. Based on the evaluation, the experts provide suggestions for refining the design to make the system more usable. These are the differences between formative and summative usability testing, and we provide an example for each. So formative usability testing is conducted through an early or middle stage of the design process. So the goal is to identify usability problems, gather user feedback, and make iterative improvements to the design. It helps the development of a product before its final version is complete. So an example, like a company developing a new e-commerce website may conduct formative testing on wireframes or low fidelity prototypes. Testers could observe users attempting to navigate through product categories and checkout, identifying early usability issues such as unclear navigation, labels, or confusing checkout steps. So summative usability testing is performed after the product is nearly finished, with the aim of assessing its overall usability, efficiency, and effectiveness. The result a predetermined usability goals. So examples of summative usability testing. So after the final version of a fitness tracking app is completed, summative testing is conducted to measure how long it takes users to log their workout or set fitness goals. So data such as task success rates, number of errors, and user satisfactions are recorded to determine if the app meets the usability standards. So evaluation of usability metrics to interfaces to an interface effectiveness. So we can evaluate them through through task completion time, which measures how long it takes for a user to complete a task using the interface. So it is like an indicator of how efficient and intuitive the system is. There is also error rates, like it tracks how often users make mistakes while using the interface, such as clicking the wrong button or entering an incorrect information into an application. So what are the challenges of conducting usability testing? First of all, we have recruiting representative participants is a challenge. So the finding participants who closely match the target user group is essential, but it can also be difficult, because if participants do not represent actual users, the results might not be accurately, like they might not be accurately reflecting the interface's real world usability. So what can I say by this? So if we are we want to conduct usability testing of a let me say the fitness of Mwele, and instead of recruiting students, we go on to recruit grandmas who will not actually use the product at the end, because it's the students who will use the product. So recruiting grandmas will not represent actual users of Mwene. So it's students who are to be recruited to use the interface, so that the results accurately reflect the user's real world usability. Let me see. So the cost is the second challenge of conducting usability testing, like cost and time constraints. So usability testing can be time consuming and costly, especially for small organization or during early development stages. There is observer effect. Like participants might behave differently when they know they are being observed, leading to biased results. Like they do not want to annoy the person who has given them an interface for the feedback. So sometimes they might give the wrong feedback, like to impress the person who has given them the interface for assessing. Yeah. Or sometimes they might give a feedback to bias the person who is assessing. There is difficulty in simulating real world use. So like lab environments can't always replicate real world problems under which users typically interact with a system. There is interpreting qualitative data. So user feedback is often subjective and open to interpretation. Users might struggle to articulate specific issues, or their feedback could be contradictory. So limited sample size. So often due to a budget or time constraint, testing is done with small sample sizes which may not capture the full spectrum of usability problems. There's dealing with complex systems, like understanding how the structure usability tests to overall, or to cover all relevant features and tasks, which can be daunting. So question number 6 is about usability and evaluation. So when I move to the next slide, I'm comparing and contrasting usability testing and cognitive walkthrough as evaluation methods, and when one might be preferred over the other. So usability testing, real users interact with the system or interface to perform tasks. So their behavior is observed and data is corrected on various usability aspects such as task completion, error rate, and user satisfaction. While a cognitive walkthrough involves experts systematically going through the interface step by step, imagining how users will interact with it to complete tasks. So the goal is to predict potential usability problems based on user thought processes without involving actual users. So when to use one over the other. So in early stage, cognitive walkthrough is ideal since it's expert-driven. It can be done before the system is fully functional, allowing for early detection of usability issues. So in the later stage or like prototype testing, usability testing is better suited for later stages when there is where there is a working prototype, as it provides actual user data and insights into how users interact with the system in real scenarios. So resource constraints, like if resources like time, budget, users are limited, cognitive walkthrough might be preferred as it is less resource intensive and does not require user recruitment. So there is also in real user feedback. So if you want a real user feedback, so it is essential for understanding how real users interact with the system. So here usability testing is a better choice. So how can analytics data be used to evaluate user behavior data on a website or app? Analytics data provides valuable insights into how users interact with a website or app by tracking key metrics and behaviors. So this data helps designers and developers understand user preferences, identify usability issues, and optimize the user experiences. Example of using analytics data, one is identifying drop-off points. So by examining the conversion funnel data, or the paths users take from browsing to purchasing, you can see where users drop off. So if a high percentage of users add items to their cart but abandon the process at the checkout stage, it may indicate a problem with the payment flow. So the action which can be taken, like simplify the checkout process, reduce unnecessary form fields, and add a progress indicator. 2, there is improving engagement with heat maps. So using heat map tools, you discover that users frequently click on the product images but rarely engage with the product descriptions or reviews. So this might indicate that users aren't seeing important details about the products. So the action which can be taken is reposition product descriptions to make them more prominent and enhance visual cues to draw attention for reviews. The third is optimizing navigation through session duration. So if session duration is low and users are not exploring many different pages, it might suggest that the app's navigation isn't intuitive or users aren't finding content of interest. So the action which can be taken, improve the navigation menu by categorizing products better, adding a search function or providing recommendation based on user history. So tracking user satisfaction via bounce rate. So a high bounce rate on certain pages, like landing page for a new product launch, can signal that the content or design isn't engaging at all enough to keep users on the site. So the action which can be taken, updating the landing page with more engaging content, optimize page loading speed, and test different headlines or images. So we have remote usability testing. The advantages of remote usability testing, it is like wider spread and diversity, convenience, effective, scalability, and the natural environment. So wider research and diversity are like you can include participants from a different location, time zone, demographics, includes diversity of your user base. So the convenience, participants can perform tasks in their own setting at a time that suits them, creating more natural experience. The cost effectiveness, like eliminates needs for travel, physical spaces and equipments, reducing overall costs. Scalability, multiple tests can be run simultaneously with less logical coordination, allowing for large sample sizes. So the natural environment, here users are interacting with the app or website in their everyday environment, which can lead to more realistic results. So the advantages, the limited observation, like where the researcher may have limited ability to observe nonverbal cues such as facial expressions or body language, which can provide valuable insights into user frustrations or confusion. So there is less there is also technical issues like variability in participant devices, internet speed, or software, which could affect performance and cause data inconsistency. Less control, like it's harder to control the testing environment, which could include distractions and other variables that may take skew results, since the researcher and the users are in different environments. So there is also reduced personal interaction. Without the face-to-face interaction, it may be harder to build like rapport with participants, potentially affecting the quality of the feedback. So in-person user testing, there is direct observation, there is controlled environment, since the user and the researcher, they are in the different environments. So there is also instant feedback and adjustment. There is also facilitated interaction. So the advantages is limited reach, higher cost, it is time consuming. There are also potential biases. So when I move to the next slide, I'm explaining the protocol of thinking loud. So the thinking loud protocol in usability testing is a method where participants are asked to verbalize their thoughts, actions, and decision-making process. So while interacting with the product, such as website or software applications, this real-time narration allows researchers to gain insights into the user cognitive processes, uncovering issues that might not be immediately apparent from the actions alone. So the benefits of thinking loud protocol: it reveals user mental model, it identifies hidden usability problems, it provides immediate feedback, it clarifies intentions and expectations, there is low cost and high value data. So the role of A/B testing, first of all, A/B testing plays a crucial role. So the role of A/B testing in evaluating and improving the user experience of a website or a software application. So A/B testing plays a crucial role in evaluating and improving the user experience of a website or application by comparing two or more versions of a page, feature, or element to determine which one performs better based on predefined metrics. It allows designers and product teams to make data-driven decisions to optimize the user experiences. So how A/B testing works? Creating, first of all, we create variants, like two variants, say A and B are created, where version A is the control, which is the existing design, and version B is the variant, which is the modified design element. So sometimes there are more variants of A/B testing. So there is random assignment. So users are randomly split into groups, with one group seeing version A and the other group seeing version B. This ensures a fair comparison without bias. So there is measuring performance. So after splitting the users, each version is tested against key performance indicators such as conversion rates, click-through rates, time spent on the page, or task completion rates. So we also do analysis after after a statistically significant number of users have interacted with both versions, A and B. The results are analyzed to see which variant performs better on the chosen metric. So how does A/B testing work? So data no yeah sorry. So on the next slide, I find benefits of A/B testing. There is that data-driven decision. Like instead of relying on assumptions or feelings, A/B testing provides concrete data to support design changes, helping teams make informed decisions. It optimizes user engagement. It reduces risk. It validates hypotheses. It improves conversion rates. There is also continuous improvement. Thank you very much. And this is the end of our presentation.